Yeah, thank you, Jörn. Welcome everybody to the Tech Talk today. Today we will talk about configuration changes in manufacturing and servicing of products, and especially use cases like retrofit, product as a service, features on demand, and order changes. So they all have in common that they have configuration changes after order entry and during the usage of the product. And we will talk today about how our configuration engine can support these configuration changes and help you to find the best way to apply these changes to a product. Before we dive into the use cases, I will go through a small introduction of the scenario and the example product we have. And at the end, we will have a small summary and some space for questions. So let me jump into the configuration change scenario. So what kind of configurations we are talking about? So we're not talking about very simple configuration changes. So when we think about something like changing a color of a product, it is quite simple what we have to do. We have to paint the product in a different color. And there is no other alternative maybe available to that one. So we don't talk about these kind of configuration changes. We're talking more about more complex configuration changes, something where you have an old product, maybe 5-10 years old, and the customer want to get it updated to a higher end speed, in that case of car, a lower fuel consumption, more comfort or something like that. And while we're talking about these requirements, we also already get some ideas in mind how we can apply these changes, because getting, for example, a car to a higher speed, there might be multiple ways how we can achieve that by replacing the engine, changing some components like the exhaust system, or optimizing aerodynamic weight or something like that. So there are various ways how you can get to the target of improving the speed or performance of a product. So what you typically might do in such a situation is you ask your engineers, and you might ask a couple of people, and they all come up with a different idea how this can be done. And the first question you might have at the end is, are these all options I have, or are there more options? Is it just these 3 they mentioned, or is there 4 or 5? So you don't know if you have considered all these options already. And the second question might come up is, which one is the best one? So do I go with the one or the other one, which is most beneficial for a specific context? And that's what we will work today a little bit on. So we will see how our configuration engine can help you to find the available options you have to change your configuration. And we will talk about how to figure out what of these options is the best one. And we will talk about the different scenarios. So if we talk about our CLM circle, we are today more in the manufacturing and servicing area. So the order change happens, of course, in the manufacturing part, while product as a service situations, so reusing of products after a certain time, or retrofit scenarios happens during servicing. When we talk about configuration changes, we also have a little bit to look at the timeline of our product development. So if you do an order change, for example, this is very close to what we are technically possible to do. So if you already have sold the machine or the product with the highest performance, it is difficult to get even more performance out of it without doing ETO. But if you have sold a smaller machine or not all the features and functions you are offering, then of course it can be done that you have some order changes that the customer wants to have more features or better performance or something like that. But that's often done in a very close to the today technical possibility. So there are not a lot of innovation changes happened in these time phase typically. When we talk about product as a service or feature on demand, we are already a bit more far away from the today technical possible capabilities. So there might be already some smaller improvements. It could be software updates or other improvements you have done in the meantime. So the capabilities you have to change the configuration are already a little bit higher. And additional information which are interested is more maybe having a very efficient change, while in the order change, you're more looking for having less impact on the production as possible when doing an order change. And when we talk about retrofit configurations, we talking about quite old machines, 3 years and even more. So let's say a customer comes to you with a 5 years old machine and he wants to get some improvements to it so that the performance is higher or accuracy is better. So you might apply a retrofit to avoid that he has to buy a complete new machine. And the innovation jumps you have here are quite huge. So you have a lot of capabilities you can apply to such an old configuration to make it even perform better or faster. Today I will use an example product, and the example will be a 3D printer, something similar like that one here, which is more maybe for the home usage, but there are also a lot of 3D printer for commercial usage available. They all are quite similar from the technology point of view. And when we talk about some key features or capabilities of it, then it is something what improves over the time is maybe the accuracy of the printed products, the complexity of the shape, so that you have more complexer structures, that you have multicolors you can print, and so on. And it might be also the speed, which gets better over the time. And when we now look into our 3 example versions we have here, they are all on a different scale, of course. So over the time, we have improved our performance of the product more and more. And these are kind of the operation triangles the product is operating on. So over the time, there are a couple of components which drive these innovations. So we maybe improve the mechanic, the motors, the extruder itself. We get faster microcontrollers, better firmware and software products installed. So all these elements help to improve in these different areas. And if we have now a customer who is on version 2 of our product, he might be interested to update it a little bit. So maybe he is quite satisfied with this, but he maybe needs a little bit more speed, but the accuracy and the shape complexity might be okay for him. Or he would like to get more accuracy, but the speed is fine of the machine. And that's something we could achieve with a retrofit. So we have now different improvement dimensions here in this graph. So we could kind of improve the complexity of the shape, which would move our current machine into this direction. We could improve it to get more accuracy, which would improve our machine in this direction. More speed goes in this direction, or maybe we would like to get a little bit of all better, so then it might go in this way. So that's a typical requirement when we have a retrofit configuration, that we would like to improve the product somehow, but maybe not to the fastest and best version, then I could buy the new one, but I would like to get something in between also to have maybe save some money. And that's a situation we will look into today in the retrofit part, how these can be done and how our technology can support this use case. And in order to be able to do that, we use our VT technology. Because the functionality we use today is very unique to the way how we execute in configuration. And for those of you who have never heard about our VT technology, just a small, briefly introduction. As usual, we have a rule authoring environment, and what makes our configuration engine very special is that we do not execute all our rules during the runtime. We pre-execute our rule set, compile it into a small solution space, so that we know all the possible combinations of the product model. And then we give the front end access to this solution space to configure against it and validate the configuration instead of executing the rules again and again. And this process here, this is our VT technology, which makes it unique, having this solution space and doing some analytics on it. And that's what we also will use. So the benefit of our technology are, there are many special USPs on our technology, but we will use today 2 of them. There is the analytics part, so that we analyze the solution space to find the best way to change the configuration. And we also will use our conflict solving capabilities to be informed about what has to be changed. If you want to learn more about our VT technology, there are other tech talks on our websites going a little bit more deeper into the technology and capabilities we have. So with that, having set the scene, we will now jump into the first use case. And the first use case I will do a little bit more detailed, step by step, seeing how the technology works and gets to the details. And the other one, we will then just apply the same technology and capabilities to the other use cases. So when we talk about the use case retrofit, we first have to talk about the timeline of a product model. Because when we have a sales timeline, it often looks a little bit like that. So we have different released version, and during the releases, we do changes to our product. So we're improving the mechanic, we're exchanging the motor. There might be some new law regulations which are popping in. We discontinue some features, we introduce new features, and so on. So that's a typical sales timeline. If I have a configuration which was sold at this point in time and manufactured at that point in time, I will have these configurations: the mechanic one, the motor one. I already was in the law regulation. I have the USB port, but I don't have any Bluetooth capabilities. And the first idea some might come up is, hey, when I want to update it to the newest status, I just apply it to the newest product model I have in the sales configurator. But the problem is, when I do that, the system only allows these elements here. So the mechanic 3, the motor 2, and so on. It don't cares about the rest, which would end up in that the system tells me, hey, if you want to get to this, you have to change the mechanic, the motor, you have to remove the USB port and the Bluetooth. You have to do a lot of changes, which at the end is kind of a new machine or product. What you was a bit more aiming for might be something like that. So you keep your mechanic and the other elements, and you're just updating the motor to get a little bit more performance here. But that's not what happens if you do this process, because the sales configuration only knows what can be today sold and don't cares about what was in the past available. It just validates against what can be sold today. So what is it? What we need is we need a special service timeline here. And the service timeline is not as it is in sales, that we phase in, phase out a lot. It is more talking about what can be combined together. So for example, we could combine mechanic 1, 2 with motor 1 and 2. So these can be freely combined. But if you want to get mechanic 3, it needs motor 2, or the other way around. If I need motor 2, I have to update also the mechanic. So these are a bit more the view I have on a from a sales perspective on the product model. So what we have to do is we have to add a couple of rules, because in the sales timeline, we do not have any rule which defines if the mechanic 1 we have here is combinable with the motor 2 we have here, because they was never at the same time sold. So there was no need to have these kind of rules. When we talk about a service timeline, then we need this rule, which defines if I can execute a mechanic 2 with an update to motor 2, so can I execute that one and this one together. So I have to apply some additional sales service rules to the model. Additionally, it could be also that some features are discontinued. So here we have sold the USB port and the Bluetooth port interface. And we can see here it was both available, and at this point in time we have discontinued the USB port. We just support the Bluetooth connection, which ends up in that this is also not longer supported by the software. And if the software don't support it, you could hardware-wise still have it, but it will be not longer used by the software. And also the law changes. If the configuration would be done before the law change, do you need to apply these now for a retrofit scenario to be up to date with the newest security laws and so on? Or can you still stick to the laws which was years ago valid when you bought the machine? So that might be also some details which has to be applied to a service model, just to mention a few of them. And if you have this model, and we now apply our configuration we had here to the service model, the system can help us to find out what I need to change to get to a better performance. So it would be now that it says, okay, the motor tool is fine, but you also have to replace the USB with the Bluetooth port. That might be also some additional changes. So that one is quite close to what we was aiming for. And the great thing on our technology is it is not one possible way how you can solve that. There might be several ways how you can solve that. So it could be that you change the motor to get a bit more performance, but you also could change the mechanic, or you could change both to even get more performance, of course. This functionality is called the minimal conflict set. So the configuration engine can give you all the possible ways how this conflict can be solved to get to, for example, faster performance or to get certain features, and can return these different capabilities to you. And that's something we will see in a moment in an example. But first, let's look into these different cases I have talked about. The first one will be applying a configuration from a past to the newest sales model and what happens then. So that's a case which is not the right way doing it. So let me start this recording. I've pre-recorded it. So we can see here that this is a quite old configuration, version 1. It's a sales timeline. And we can see here the different configuration we have applied to it. You can see at that point in time, there was not a lot of variability available. So we have these, and now we go in and change the date. So we remove the old date, we change it to the date yesterday, move to the version 3. And what now happens is that the system tells us, okay, you have to nearly change everything in your product model to get to the newest version. And that's what I said is not what we was aiming for, because we wanted to keep a certain amount of our old product and just update it a little to the newest version. So let's do the same with switching, instead of in the timeline of the sales configuration, switching to a service timeline. And we have here the same configuration again. So it's the old one, version 1, the sales, the same configuration applied here. And we're now changing the configuration, the date again to the newest date, but this time we're selecting the service timeline. So you can see when you select the service timeline, it also using the service model here as an example. And what we can see is now no conflict, and we have all the capabilities available now here. So everything what we have developed in the meantime and is still applicable is now available here in the configuration. And based on this, we can now force or execute retrofit analysis. That's what we will do in the next video, receiving the minimal conflict set. So starting that one, we are in the service model still. And the first thing we will do, we will switch the view from the sales view to the service view. So there's a separate view, which shows a little bit more information. And we have one additional tab here, the update tab, where we can now change the print speed, for example, or the shape complexity. I will focus here a bit on this print speed. And when we change it to a very high performance, we have, of course, to change a lot of functionalities to get to this high performance. But if we use a lower performance, like 100, we can see I just need to change the motor here in the motor controller. Or if we even go with lower performance, we can also achieve that with just software updates. But at any point in time, we can ask the system, hey, are there more capabilities to solve exactly this conflict? And that's what the system gives us in the minimal conflict set functionality. When we look deeper into the conflict details, we can now see what combinations are available here. And it might look in a first moment a little bit strange what information are presented here, but let me give you a little bit more introduction to what we see here. So we will now focus a little bit on one group here. So we had 8 conflicts or 8 groups, minimal conflict sets received, and we will focus on these 3 here. And we can see one element is the entered speed, the 50. And for each group, I have to remove one of these selections to fulfill these one. And I have to fulfill all these groups. So what we can see is when I, for example, change the application version, I can get all three solved here. If I change the motor controller, I get two of them solved, and then I also need to change the motor itself. Or, for example, when I change the mechanic, I also have to change the print plate as well. So we have here, in summary, three options how we can solve these conflicts to get to these higher performance: software update, electronical update, mechanical update. And that's what the system is returning here to us, and we can use this information. And with help of our solution space capability, we can now remove these elements for each of these conflicts and see what combinations are now available to apply to get to these new performance speed here. That's what we see in the next video. We are here again in our service configuration. We have the service start applied with the configuration, and we now will go into the solution space explorer view. We want to see the combinations for the firmware and application, and we have applied here the configuration we have without these both versions available. And if you now ask the system what combinations are available, we can see the combinations of the firmware and the application. In such a situation, we maybe go with the newest possible version, but you theoretically could also apply some combination in between. But as usual, you would maybe focus on the newest version here. So that way, the system can tell you what combinations are now become free after removing this conflict, and you can see which one might be relevant for you. So having this information collected, what are the minimal conflicts? What are the possible options I have? I can combine these with additional decision criteria. Because just knowing that I can do the change in three ways, so we had the software, mechanic, and motor, software, mechanic, and electronic change, it not automatically means that we know what is the best one. So doing this change, we have the conflict, we have the minimal conflict set, so we can adjust, extend it with additional decision criteria, and we can now build a decision matrix for it. And this one can help us to understand with our founded options, which one is the best one to go forward with. And it's no surprise it's the software one, but if we remove that one, it could be that the motor is a bit cheaper than changing the mechanic. The downtime might be a little bit higher, but the motor is available on stock while the mechanic has to be ordered. So maybe when we just look at these both, the motor might be the best way to choose for this retrofit. So that way the system can help you to find the best possible way when you combine it with other information from your company together with the minimal conflict set. And in a similar way, we can use these functionalities also for a product as a service scenario. So in a product as a service scenario, we have a customer buying a machine. He rents it for a while from us as a service, and after 3 to 5 years, it returns to us. And after a while, we might get up a machine pool with a couple of machines. And if now the next customer comes, wants to have a specific configuration, we can try to reuse one, but it never might fit exactly the same configuration the customer is asking for. So you might take a compromise that some functionalities are not there. Or as an alternative, you could get a complete new machine. So I produce a new one, but I don't reduce my machine pool here. With a minimal conflict set, we can support a third case, very nice, and that's the update case. So with a minimal conflict set, we could now compare which machine comes closest to what the customer needs and has less rework needed, cost, time, or whatever the decision criteria might be, and could find the best machine which could be turned into what the customer is asking for. So that way we also can help you to find in your machine pool the best fitting machine to what the customer requesting. Another use case is a feature on demand use case, quite similar to what we have seen in the retrofit case, but with a small difference. So we have again a sales timeline with some mechanical components, and I now put into the timeline more some features like a specific file format we can import for 3D printing and some software updates. And we can see when we have a configuration at that point in time, we only could use the sketch files here. But if I now want to get these CAD file support, I need to update, of course. And what I now want to avoid in a features on demand scenario is that the system says, okay, you can get this functionality, but you have to change your motor or your mechanic or something like that. That's something we want to avoid because feature on demand is a bit more self-service. So customer can choose features which are available for the configuration he has on site, the physical product. So what we can do here is that we put the configuration into two phases. So one is the physical configuration, which becomes locked. And the other phase is the flexible one, the features and functions you can change on the fly, as well as the software changes. Because if the system says, hey, when you change the software, you could get this feature, it might be okay for us. And the nice thing putting it into phases is that the conflict avoids in the suggestion of changing that any of these will be changed. So they become locked, and the conflict resolution will only apply changes to the phase 2, the elements you allow to be changed in a features on demand scenario. And a last use case is the order change process. So also here, we have order entry. We're starting our production, and at a certain point in time, we have a specific status. So we have half produced our product, for example. And then a customer has the idea of changing the product, something new feature, more functionalities, whatever it could be. And at that point in time, you now have typically a problem because you have to apply these changes somehow. And there are some different ways how you can do it. There might be even more as these 4, but I just picked these 4 as an example. So you could cancel and disassemble what you have done so far and produce a new one. You could deallocate it and produce it on stock and produce a complete new one. You can produce it as ordered and do afterward a rework to the new version. Or you change your production on the fly, which is of course not the easiest way doing, but it might be also a way applying the change. And we will now focus a bit on these both here. And when we do that, we have again our initial configuration, that was the order entry configuration, and now the order change configuration. We have the conflict, of course, the changes which has to be applied, and we might have some suggestions how these changes can be in different ways applied. If you now combine that with information which are relevant for an order change, which might be cost, production status, stock availability of products, we could use this information, solve the BOM for each of these minimal conflicts, and see what might have the lowest impact on our production. That of course requires that the production system gives us a very detailed information about what is the current status, what is already implemented, what is still open to build, and so on. But if you could receive such an information, we could use the minimal conflict set to figure out which one has the lowest impact on the production. And it looks like that the gray one is in an area which is not yet started on production. So it might be maybe that the gray one could be a quite good one, but on the other side, it could be the most expensive one. So putting in these different decision criteria could help you to figure out what of these combinations might be the right or the best one to go forward with. Yeah, and in summary, just quickly what we talked about is now the different use cases. So when we have a conflict, we not only can solve it in one way, we could solve it in several ways. And that's what our VT technology offers you, it's information about what are the different ways. We can offer this information to service and manufacturing, and then support the use cases like an order change, support the use case of features on demand, support the use case of product as a service, as well retrofit scenarios. So that way we can help you to optimize, speed up, get better quality, and maybe also automate these processes a lot. So that's the tech talk for today.
Thanks a lot, Heiko, for your presentation. We're running a bit out of time, I know. Let me just take one question. There's a top question here is, can we automate the process of finding the best change of the configuration?
Yes, that could be automated. So what we have seen here, the solution space and the minimal conflict sets, that's also available underneath in the APIs. So the configurator was just a UI on top of that. So you can use these APIs to automate this process. What we deliver from Configit side is the different options you will have to make your changes. And then, of course, you have to bring in your information from the company about stock availability costs and all these other decision criteria you would like to feed in and build up your individual decision metrics for a product change. Yeah.